Hello, everyone. Thanks for coming. My name is Dario Laverde. I'm a Senior Developer Evangelist for HTC. And what I want to talk about here, as you can see from the title, it's Android and or Unity for VR and more. It's primarily a primer for Android developers who are new to Unity. So I just want to see a show of hands. How many here are new to Unity? Okay, cool. How many are pros of Unity? Okay, because I'm not a pro either. I just pretty much have a year thereabouts. I've been doing Android since 1.0, and as it turns out, a couple years ago, there was this Oculus startup, and then Cardboard came out, and then at work, where I was doing Android full-time, we also have a headset at HTC called the Vive, and suddenly I transitioned from doing Android 100% of the time to now just a smaller percentage of the time because I shifted to doing VR with Unity. So what I want to talk about is basically what and why Unity. And again, for those who are new, I recommend if you have your laptops out, feel free to download it. I'm going to go step by step on how to get started very, very quickly and show you how easy it could be. Primarily, it consists of Unity. The current version is 5.3.3. 5.4 is in beta. So primarily it's been used previously for primarily gamers who want to port their games across a lot of platforms. That's its strength. Essentially, we have developers who target, iOS, Android, Windows, and Unity makes that possible. And the way it does that is it has these runtimes that you have to select when you're installing. So this wasn't the case earlier. It used to be a huge download. Now, when you start up, you have to actually select which runtime you want. So if you want to use primarily Android, you have to make sure you check that as a separate download as part of the install process. So I originally wasn't a fan of Unity. I found it to be, because I've previously developed games using OpenGL, and as a hardcore native developer, I always felt that real programmers roll out their own game engines. That's not true anymore. You need to have a tool like Unity, and not just Unity, there's a number of competing tools like Unreal and CryEngine, and a number of them that all are now supporting VR as well. So the intimidation when you first start looking at Unity is you see, yet another IDE. You think of, Illustrator, Photoshop. I got to learn another IDE, and basically, it's a little challenging at first. And again, I want to reiterate what Unity is for those who don't know. The number of apps that I've been seeing developed for VR now have been developed with Unity. 90% of those apps, they have such a great market share. It's hard to ignore. So even if you're a fan of Unreal, and they may have technical merits that are better in some areas, you can't ignore Unity 3D. So why for Android developers? Well, as it turns out, Google is now focusing on Unity with both the Cardboard and Tango SDKs. Obviously, initially they came out with Android support in Java, but slowly they realized, especially with Tango, how easy it was to get started with Unity. And now you'll see more sample code for Unity versus the Java. So that's an indication of where we're going with, especially for VR apps and AR. So it's both hard and easy. So when I first looked at it, my reaction was, I got to learn a whole new IDE. Part of the mental block, I think, was that you're so accustomed to your developer IDEs for Android, be it Eclipse or Android Studio, IntelliJ, so forth, that you get used to a certain mode of developing. It requires a little different mindset because now this is obviously used also by designers, not just programmers. So you have to like put that aside and not let that get you down. In other words, instead of asking, where is this tool? Where is this ability to do this workflow? Why doesn't it do this? All those stumbling blocks. Like initially, I found source control really painful, but then you start realizing, this is a tool. Let's just get the job done, and let's just, set aside those questions. Also, one of the powerful things in Unity is that they have a store, an asset store, and it lets you get up and running with art, even if you're not an artist, very quickly. And for some people, they may think, oh, well, I should just hire an artist, and ideally you should, but there shouldn't be a stigma of using this art from the store, because I've seen a lot of apps use asset store assets, and it's almost a norm for a lot of developers in VR as well. So I'm just going to quickly go a quick overview for those who've never really played with it. So at first glance, you have these views, these windows, primarily those 4, and I'll quickly go through those. We have a scene view. That's the middle there. And that's the current scene you're working on. So everything's organized in scenes. Your project contains a number of scenes. You can save them separately or all at once with your project. Those scenes is where you put your game objects. Now, whether it's a game or not, it could be a training application, a VR experience that has nothing to do with gaming. But the convention is we call these scenes, and game objects are what's in the scenes. And that's from a point of view from an editor's camera. Now you can have the player's camera is going to be separate from what you're seeing in this middle scene view. In fact, it's the game view that's going to have the camera that the player is going to see. All right, so let me just quickly go through this visually. So we have a project window, and this is where you maintain all your assets and external plugins and so forth. Generally, it's here where you organize your resources, your third-party assets and scripts and so forth. I mentioned the scene view. We also have a hierarchy window that shows you what's currently in your scene. And what's currently in your scene, you can focus on what's in the scene by selecting one of the objects in that scene using the hierarchy window. If you select an object, and I'll switch over to the IDE in a second, you will get focus on all the properties of that object. That's what the inspector window is. And then finally, we have the toolbar where we actually have some navigation tools as well as where you actually start playing your game, pausing it or moving on to the next scene. One additional thing that's not obvious is that when you build, you have to go to File, Build Settings, and you have to target the build target that you want. In this case, we're going to focus on Android because we want to get a cardboard app or a Tango app running. So you need to select this for your project and set the settings under the Player Settings button there, and I'll show you that as well. Now, generally, I think Unity has done a great job for tutorials, video tutorials, and so forth. They actually have a lot of workshops constantly going across the country. I would recommend catching one of those. One of the Hello World tutorials that they have is called Rollerball, and it's a sequence of about 9 short videos, 5 minutes each. But it uses a learning technique that they use in their on-site workshops, which is very much hands-on. But you actually pay attention to the sequence, the video first, and then you go back and go through a hands-on learning cycle. Now I'm going to actually switch over to the actual IDE here. So generally, you get started by creating a new project. So I'm going to create a new project. Let's call it Droidcon Unity. So this is my previous project. I'm just going to save that, and let that close. Generally in Unity, you're not allowed to have more than one project open. There's a workaround which I'll show you, but generally you only have one project open at a time. So here you can see I have my different views. You can arrange them in different ways. The layout is customizable. And generally I see that the different tutorials will use different formats. Generally I like this one where you have the scene on the left and the game view on the bottom. Here's my hierarchy. So every scene when you start up by default has a camera, a light, then it's up to you to start adding things to it. So I'm going to quickly just add a couple objects just to get a simple example going. I have a sphere, but before that I could probably add a floor, so I'm going to go to add a plane. So now when I select an object in my scene, I can actually start changing properties in the inspector. So I'm going to raise the height of this because the ball is half immersed in the floor there. So I'm going to make it go up a bit. In fact, I may make it go up a little high. Just maybe show some animation with physics. So for every object, I can start adding, for example, physics to this by using a rigid body. Now, again, a lot of this terminology is when you start, you get used to it after a while. Like rigid bodies are required for objects for physics. There's also the notion of reusable objects once you define them as prefabs. So it's a matter of getting used to the different views, the different terminology, and so forth. So I'm going to save this scene. I'll call it test. And that appears as a scene in my project. So all I have is this one scene in the project. If I create a complex object or a family of objects, because you can nest objects, then when I want to reuse it in a different project, I can save that as a, let me just try that right here. So I can save this as a prefab by dragging it down into my project. And now this sphere is reusable in different projects. Now, granted, in this case, I didn't really make anything complex with the sphere, other than giving it a rigid body. That's the only thing I did. So now I can create other spheres by dragging it back. Let me just move this. So now I have two spheres, but I won't have to add a rigid body to the other one because it's a prefab, meaning it's saved all the properties that I saved earlier. Let me just show you this running. So we run this and you can see they both drop physics out of the box, and that's about it. Now, let's say I want to start using cardboard. I have this existing scene and I want to add cardboard. So I would go to assets. In this case, I already downloaded it, so I'm not going to download it again. But basically, I would import a package, a custom package, and I would go under my cardboard folder and import the SDK for Unity package. Now, you can actually save your own Unity packages as well as a single component. So here I'm importing this Unity package, and I'm going to be able to have this Cardboard SDK plugin included into my project here under Cardboard folder. This Cardboard folder includes all the things I need, like prefabs. So for instance, if I want to start having a stereoscopic view, I can just drop this prefab in here, get rid of my default camera because I don't need it. The Cardboard main includes one. And it includes a stereo renderer, a representation of the head with the main camera. And in fact, if I run this, we have cardboard showing a ball falling there. So this is how relatively simple and quickly you can get up and running. And with that, let me just go back to the slides. Now, there's some best practices that you learn the hard way, or if you read up on best practices, you'll learn that way. So I mentioned earlier I struggled a little with source control, getting stuff into GitHub. It turns out there's a lot of metadata for each one of these objects. Obviously, the positioning and sometimes even the history of where you place these things in every scene, there's a lot of information. It could be stored as binary or as text. I would recommend storing it as text, so you can do diffs easily and so forth. It's also healthy for developers to have a second copy to check out for sanity testing, because of the fact you have all this metadata, and especially with versioning, it gets a little out of control. If people are not in the same version of Unity, or they're using an asset that's a different version and so forth, it's easy to get lost and make a lot of changes, and for sanity's sake, do that. If you're doing game levels, if you're describing your scene dynamically, make sure you have a different system for editing. Use XML to save that. It's just easier to deal with than dealing with the entire scene and managing that. Always place the world at 0, 0, 0. It just makes things easy. You can group all these objects in your scene and label it world, and just make sure the world is at 0, 0, 0. Also make every game runnable for every scene. In fact, let me go back and show you the player settings here. So I've been running this in the game window of the editor. This is not the actual target, which is, I want to have it on my phone. So for that, I need to go to File. Oh, by the way, this is still running. There's a trick to making this appear blue, or you can pick any color, so you know it's still running. I need to make sure I stop it, because I would lose changes if it's still running. Anyway, File, Build Settings, this is where you target Android. And under Player Settings, this is where you start putting some familiar information for Android developers, such as the bundle identifier. This has to be unique, so I'm going to call it Droidcon SF, if I can spell. And also, for Cardboard, your layout is always going to be landscape left. So you shouldn't have anything else but that selected. Now there's a lot of other settings, but this is the minimal you need to just make sure you get an Android APK built and ready to run. Now the other thing is you have to include what scenes you're going to build. So I'm adding the open scenes here, which is that test scene. I can have maybe a dozen scenes, and I can decide at this point which scenes are going to be included in my APK, and they generally run in order. So make sure that your main intro scene is up top. Now when I build and run, I can actually start, I'll name this APK Droidcon SF. And while that builds, I'm going to go back to slides. So some best practices, some more. So you have to always organize your scenes, organize your objects inside those scenes, make sure you nest things logically, avoid branching assets. Again, I already described how it could be held to manage source control with a lot of assets and metadata. Make use of test art. There's a lot to be said about keeping your assets small initially and very simple, like using basic geometry shapes that come with Unity instead of dragging in all these third-party assets. Always have debug options with every prefab. Have shortcuts within the game for screenshots, saving the world info, and so forth. So now I'm going to switch over and talk a little generally about VR for those who are new to VR. As I mentioned earlier, a lot of the demos that Google's working on for VR are built with Unity 3D. At last year's Google I/O, they had an interesting code lab. They had an existing game, and I can show you that in a second, where the part of the lab was converted to run on cardboard. So it was a 3D first-person shooter where you were shooting androids. And they went through step by step, and I recommend everyone to take a look at that as maybe their second lab after they're doing the Hello World exercise from the Unity site. Part of the importance of VR on mobile or even on PC is maintaining frame rate. And this is what can break an experience when you see a lot of dropped frames. So you have to design thinking optimize while you're coding. Don't optimize later. Basically, you need to maintain 60 frames per second on mobile devices. Any less than that, you're really going to get people nauseous. And there's a lot of things that go into cardboard, such as the distance between the eyes, also known as IPD. You don't have to worry about it because cardboard under the covers does a lot. A lot of the fixed IPDs are in the QR code of the manufacturer of the cardboard. But ideally, you would want it, if it could be adjustable, that's what you want ideally, because every person, it varies a lot. Some general VR concepts that was presented by Google at last year's I/O at the VR session included having focus on convergence and focus when you're developing, keeping in mind field of view. There's an ideal, which most headsets are not reaching yet, but in the future they will. You have to keep in mind what it's being done for you as far as the lenses are concerned. So every lens is different, and that's why information is important. That QR code for cardboard, because it's going to tell cardboard SDK how much of a barrel distortion it has to do to compensate for the pincushion distortion that the lens does. I'm just quickly going some general design guidelines for VR. Don't drop frames. Don't fade to black. Don't move the player. Always be sure where you start them, and be careful with visual effects, because again, this is meant to be immersive. So you have to make sure you're not going to induce any phobias. And some more designing for VR. You do experiment with teleportation or locomotion, as a lot of people like to call it. But generally, for cardboard specifically, you have to use this gaze cue, this reticle, and that's how you're going to select objects. Because for cardboard, you're always holding the cardboard. There's no hand controllers, so you need something to be able to select things. And you can give cues as to where you want to direct them, like using light and so forth. Now, for all these guidelines, there's a convenient application for cardboard called the Design Lab VR app. And I recommend looking at that because they illustrate each one of these. In fact, each one of these listed here, they go through an example within the app, so you can actually experience every one of these principles while you're actually within the VR. So it's important to try as many VR apps that are out there, so you get an idea of which ones are using these principles, which ones make you sick, what to avoid, and so forth. It's a lot of trial and error right now for VR. A lot of these best practices will be refined over the years, because I think some people are breaking rules successfully. So we'll see what happens. For cardboard apps specifically, there's some guidelines on the app itself as an Android app. So you have to still follow some guidelines as far as using material design. Make sure you mention cardboard instead of virtual reality, which is interesting. And make sure to tell them to get cardboard if they don't have it. And there's also a fallback you should do with cardboard, is to always make sure you move from stereoscopic to, and I'll show you a demo how that works. So you can support, if I don't have a cardboard with me, for example, so if I want to run a cardboard app, I basically, let me see if I can get one running here so I can show you. Can toggle between stereoscopic and just single screen. So for example, let me see if I can get this shown here. There you go. This is what's on the phone right now. So this is, it's disconnecting. Hold on. Oh, this is the ball I created earlier. But what I want to show you is a different app. So it's not really coming up quickly. Right, give me a second here. Really slow frame rate using a Android screen monitor here. All right. So what I'm going to show you here is, earlier I mentioned there's the code lab. And here is the finished code lab. As soon as I can get this showing, because the frame rate's really bad, I should fix the orientation to landscape or otherwise. All right, so this is a scene, a menu scene, and I can toggle the cardboard mode to show just a single screen instead of stereoscopic. And it's a little slow. But that's important to give users who don't have cardboard the ability to experience this, because they can still experience it using the accelerometer to look around and so forth. So here it is, the single screen. And then I start the game. And here's that first-person shooter where I shoot balls to androids. You can, for those who can see at a distance, you can see it here. The frame rate's too slow to actually appreciate this. But basically, this is what you're building with the code lab. And initially, you're given a game that's a single screen, and you just go through the steps of making it compatible with cardboard. And it's not just, let me go back to the slides. It's not just making it stereoscopic. You have to consider inputs. Okay, so for the sake of time, I'm going to quickly go through what Cardboard SDK provides. It's essentially the ability to create a new VR Unity project from scratch or adapt an existing one. There's different approaches. And in fact, let me jump to that. Hold on. All right, these are the steps I think that are really important. So I kind of showed you a little bit of that with that starting a new project from scratch. I just dropped a cardboard main prefab. I get the stereoscopic support. If I had an existing camera that's been already modified and it's too complex to drop and replace, you can just add a script called Stereo Controller, or you can also, in fact, let me demo that. It's easier to show you. Let's say you had a different camera here. You just add a camera. And you had an existing app. It was really complex. You had a lot of different image effects and so forth. You can just right-click on here and go to Component, Cardboard, Stereo Controller to add support to that camera. And it'll add the right scripts that you need. And that's the other way. So I should show you two ways. You drop a prefab from here to here and you're done, or you modify a camera using either dropping the script manually yourself or using component, Cardboard, and adding the component you want. Now you notice there's a number of things here. Gaze input module. So that's how you would add gaze control here. Let me just go back. So generally, you're adding two components, the stereoscopic camera and this 3D user interface tools, just like the gaze input module. There's also some scripts that help you toggle between the 3D and the 2D, I mean the stereoscopic and the non-stereoscopic views. And this other demo, which comes with the SDK, basically allows you to chase this cube. In fact, let me see if I can get that running for you. Oh, and I kind of skipped that. You probably noticed that slide that I mentioned about opening different instances. This is what you do on the Mac. Anyway, on Windows, I think it's much easier. You can create a separate shortcut. Basically, let me just do that here because I don't want to close one. I want to keep one open. When you're learning, it's good to have two open. Obviously, it uses a lot of resources, but this allows me to pick another. So that one's already open. I'm going to pick another one, maybe cardboard test, which has this example that comes with the SDK. So when I run this, and I failed to mention that you can actually use Alt mouse to move around within the editor. So you don't necessarily have to, obviously it's a lot easier to test within the game window than always having to upload the APK to test. So you can navigate here. It uses the standard fire button mapping for left click to do the shooting. So here I have it within range so I can shoot. And now the cube disappeared and went elsewhere. So the purpose of this, the point of this is to center the cube so it turns green, and then you can click to shoot it, and it'll pop up somewhere else. Now you'll notice there's a particle system here that's not present in the Java version of this. And again, this shows you how much you can do very quickly in Unity, which is why you're seeing more examples in Unity. So let me stop running this. If I select the cube, you can see there's this particle effect that you can add that makes this happen. All right, I want to talk about, oh, and I have another example code that Unity let me post to share with you. And again, you'll get these slides. If you want to have a first-person shooter with this interesting models and start converting that to either cardboard or Tango, I found it. I did a port of this to Tango, and it worked really nice because Tango gives you positional tracking. So if you're not familiar with Tango, there's actually a third-party headset. You can actually use Tango as a headset. You can also use Tango as a controller if you have two Tangos, or you can use a phone as a controller using this third-party open source library. But just to give you a little peek of what you could do with Tango, in case you haven't seen what VR projects Tango can do, if I can click on this link. While that ad plays, Tango essentially gives you motion tracking, area learning, and depth perception. And pretty soon, and I'm not focusing too much on Tango because basically the tablets are end of life. Pretty soon we'll see a phone with Project Tango supported, and Lenovo announced one. And Qualcomm and Intel are also partners for the new reference design for a phone factor-based Project Tango device. Let me see if I can go back to that YouTube video. Here we go. So in these examples, you can actually do positional tracking because of the depth perception, and you can walk around. So that changes things because now you can have the ability to have this immersiveness, this room scale VR. So when you're designing for room scale, then you have to be a little more considerate about some of these best practices. You can't move the player. You have to allow him to walk through walls or basically map the walls in your virtual world to the real world. And you can get started with Tango and Unity very easily using their motion tracking example. This example basically shows you, it leaves a trail of where you've been, and that allows you to do positional tracking. Now, I mentioned earlier about using Tango Tablet as a controller. This developer has developed very simply using Unity the ability to use Tango positionally, so you can actually have controllers in positional space. Now, there's always a problem with drift and lighting with Tango in general because it uses a motion camera to do depth perception. But it's a way to get started unless you can move ahead to a higher tier experience like the HTC Vive. All right, so mixing Unity and Android. So basically, there is a lot of support and a lot of plugins out there in the asset store to support Bluetooth, Wi-Fi, so forth. But if you find an API for something that's not covered already, there is a way to write your own plugin for Unity to access Android code, be it via JNI low level or using a Android library to connect to. Just a little note about mapping coordinate systems. So for example, Tango and Cardboard had different coordinate systems, and Unity had a different coordinate system altogether, so it's a little tricky. A lot of this math is taking care of you for underneath the covers, but sometimes you do have to worry about rotation calculations, and that's where quaternions come in. So this is the best definition I've seen for quaternions. I'm gonna leave that for homework to understand what it is, but basically it handles some of the issues you have with rotations when you're having angular movement in 3D. You want to be able to have an easy way to using almost like a matrix operation to handle that for you, and that's what quaternions does for you. Unity and Java. So Unity, the Unity engine, Android JNI, is available to you as a wrapper, and you can use that for JNI. For accessing Java directly from C#, you have these helper classes, Android Java class and so forth. So you can actually access that, and you can actually have, for example, the ability to do more on your device that way, communicate with other processes and so forth. So basically, you need to create an Android library by just changing things around a bit and just producing a jar file that you can now drop into your Unity project. Here's an example. It's just simply sharing text to a chooser, so you can share something from within Unity to having a chooser, and you just share text to any of your receivers that support it. So essentially, you add, like I mentioned, you add the library jar into Unity project, and then you essentially put it in the plugins folders, the specific places you have to put it in, and then you can start using it. Here's what the C# for this example would look like. So you have call share app method that you can call from any object within your scene, and then you would use the Android Java class utility class to help you access the current activity, and then you can just send your text, and that's it. Generally, you want to abstract input, and I think it's very important to understand that every time you have, so one of the ideas I had was, for example, is to use a Bluetooth BLE like clicker instead of having to touch the screen every time. Because some of these headsets, like that big headset for the Tango tablet, it's just such a pain to actually touch the screen for input. So one example, obviously, is to use a controller, a game controller, or use a button. So for that, for example, you would want to abstract your input. Now, Unity has some abstractions, but they're very limited. They just worry about porting it across mobile phones, and if you want to add a new input, you should have another layer. This is where dependency injection can come in and help you abstract that. There's also some popular frameworks that do this for you. That's available on the Asset Store, and I believe one of them is open source as well. Rewired and In-Control are very popular with some of the VR developers I know in trying to wrap different controllers for different VR headsets in an abstract way. So that way you maintain one code base and target as many headsets and so forth. There's a wiki on Unity 3D that goes very much into detail about dependency injection and so forth. And again, we're talking C#, so there's different aspects to the language that we're not used to from Java, like using link and you know, a lot of these language abstractions that you can use. And here I have some additional resources. Basically, all this will be available, the slides will be available, so feel free to explore. And if you have any questions, you can ask me now, or you can contact me on Google+, and that's the end of this session. Thank you.